Hello and welcome to today's math lesson. Today we're doing chapter 12, lesson 3. So we've been working with the Pythagorean theorem and the converse of the Pythagorean theorem. All right, so we're going to look at this and just take it one step further, and we're going to develop a new formula, and it's going to be called the distance formula. So let's look at this problem right here. If we've got the points -3, -5, 2, -5, and 2, 7. We have a triangle here, and because it's graphed, we can see that this side right here and this side, one is exactly horizontal, one is vertical. So this is making a right angle, so we have a right triangle. So what we've been working with so far has been called the Pythagorean theorem. And what we've done is a squared plus b squared equals c squared. And these are the legs. So because this is graphed, we can actually count 1, 2, 3, 4, 5. So I know that the length of that side is 5 squared. And because this is exactly vertical, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus 12 squared equals c squared. So this looks no different than what we have been doing. So we've got 25 plus 144 equals c squared. So this is 169 equals c squared. So we're going to take the square root of both sides, and c is 13. Now c actually represents the length from point A to point B. So the length of AB is actually 13 units. Well, if we look at this, do you see how this is point B and this is point A, and they both have ordered pairs? Well, we have something that's called the distance formula. So the distance equal, like c equals, and then what did I do? So it was just c and not c squared, is I took the square root of that. So when you take the square root of that, let's look at these two values right here. If we take the two x values, x1, and subtract x2, and square it, because that's what we did right here, is we squared this. Okay, so let's take the two x values and subtract it, and then add them to, and let's take the two y values and square them and see what we end up with. Okay, x value. So I'm just going to circle this x value and this x value, and I'm going to subtract them. So distance equals, and that first x value is 2 minus, and the other x value is a -3. Okay, and then I'm going to do the same thing for the y values. So these y values are going to be 7 and -5. So I take 7 minus a -5 and square it. Now let's see what happens here. 2 minus a -3, that's the same thing as saying 2 plus 3. And what is 2 plus 3? Isn't that 5 squared? So don't we get 25? Well, don't you find that interesting? Because isn't that this first leg here that I had 5 squared, and I got 25? That's the same thing that happened right here in the green with those x values. Now let's see what's going to happen in the black when I have minus a negative. That's 7 plus 5 squared. So I have plus 7 plus 5 squared is 12 squared, and that is 144. So let's look over here and let's look at the other leg. Well, isn't that 12 squared? And I got 144. That's exactly what I got in the black. So now I'm to the same point where I take 25 plus 144. That's the same thing. It's still 169. And then you get the square root of 169 is 13. So if you look here, we solved this by using the Pythagorean theorem. And then we also did the distance formula. So where did that green 5 come? Well, that green 5 came from us taking these two x values and subtracting it. All right, let's try another one here. All right, so we're still finding the length of AB, okay? And if we look at this, we have an exactly horizontal and an exact vertical. So this right here is a right angle, which means we can use the Pythagorean theorem. So let's count. This leg is 1, 2, 3, 4, 5, 6. So this length is 6, and let's count up. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. So if we're going to use the Pythagorean theorem, I'm going to set up 6 squared plus 8 squared equals my AB squared. So I have 36 plus 64 equals AB squared. So 36 plus 64 is 100 equals AB squared. So the opposite of squaring, remember, we're going to take the square root of both sides. So I get 10. So the length of AB, the length of the blue side from point A to point B, we're saying that the length of that piece is 10. Okay, now, remember in this one, we're adding a new thing, and it's called the distance formula. So the distance formula here, remember D equals, so that's where we get C equals, and what did we do? We took the square root, so taking the square root. And what are we going to do? We're going to take those two x values and subtract them. And we're going to add up to the two y values. So basically, this is just your Pythagorean theorem. Okay, so it's squared and squared. That's where we get this squared and this squared. And now, where do we get that 6 from? Okay, so let's go in here. And I'm going to use red. So I'm going to take this x and this x. Okay, those are my two x values. So distance equals the square root. And we're going to take 8 minus 2 quantity squared. Well, what is 8 minus 2? 8 minus 2 is 6. And 6 squared is 36. So see how I started with 6 squared? By me taking the two x values and subtracting them, I get that exact same thing. So let's see where we get this 8 squared. Okay, that's the second one. So I'm going to use the y values. Okay, so I'm going to add to it, and I have 6 minus, and what's this other one? A negative 2. So what do I have here is 6 plus 2. 6 plus 2 is 8 squared, and 8 squared is 64. And that's exactly what I have right here. 36 plus 64. So you can see that this distance formula and the Pythagorean theorem are basically the same thing. So we have the square root of 100. So this is 10. So we got the distance between A to B is 10. Okay, and that's what we got using the Pythagorean theorem. So why sometimes do we not want to use the Pythagorean theorem? Sometimes we just want to use these endpoints. Now, not necessarily here on this one, but sometimes when we get to really big numbers, we don't necessarily want to graph things. But if we want to know the length of AB, we need to find this ordered pair for A. So what do we have? 1, 2, 3, 4. So that is a negative 4, 2. And B looks like it's at 1, 2, comma, how many up is that? 1, 2, 3, 4, 5, 6, 7. So if I give you two ordered pairs, can you find the length of AB? Well, can we use this distance formula? So remember, I'm going to take the x values, x and x, and I'm going to subtract them. So negative 4 minus 2 quantity squared. Now I'm going to go do the same thing with the y values. This is a 2 and that's a 7. So 2 minus 7 quantity squared. So negative 4 minus 2 is a negative 6. Now make sure you put parentheses around this and square it so you get the right answer of a positive 36. If you just go -6 squared and put that in your calculator is going to square 6 and get 36, and then it's going to put a negative in front of it. So make sure you put parentheses around that if you're going to use your calculator. All right, in the blue one, 2 minus 7, that is going to be a -5, and square it. And -5 squared is 25. All right, so let's add these up together. 36 plus 25, isn't that 61? And now a lot of times they're going to have you round to the nearest tenth. So now you're going to take the square root of 61, and this is approximately 7.8. Okay, another way we could have done this is we could just make this into a right triangle. So we could count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So we have 6 squared plus 5 squared, which is 36 plus 25. This is exactly what we have here. Okay, one final example here that we're going to do is, this is the reason. Do you guys want to graph the ordered pair 10, 20? That's not horrible. But how about this one right here, 280, 164? Do you want to graph that so that you can do the Pythagorean theorem? Well, some of you might, and some of you might not. So that's why we have this distance formula. Okay, so we're going to take the x values and subtract them. So 280 minus 10 squared plus, now we're going to do the same thing for the y value, so that's a 20, and that's 164. So we have 164 minus 20 squared. All right, so 280 minus 10 is going to be 270 squared. 270 squared is a really big number. We get 72,900. 164 minus 20 is going to give us 144 squared. And 144 squared is 20,736. So now we're going to add those two numbers together. And I got something like 93,636. So now we need to remember to take the square root of that. And I got 306. So do we have any labels here? Find the distance between our house, a third point. Oh, they don't tell us distances. So I don't know if it's miles, meters, feet, but it's 306 units, we'll just say. Okay, so using that distance formula could be effective and efficient when we have really big numbers. All right, good luck on your homework.